All right, we are going to now look at a short summary on the topics of correlation and regression. We will come back and look at an example of correlation in detail on Excel, as well as some of the nitty-gritty, but this is going to be an overview in terms of the concept, interpreting correlation coefficients, and also applying what we're learning about. So here, in terms of these notes, the deviation correlation part 2 notes, I say you can skip this part. It's good to read through and to understand, but I've ripped these notes from a headline in the sense of they're very concise, and we can look over. We aren't dealing with cross tabulation stuff and independent and dependent variables and functions and that sort of sense, because we want to look at more applied examples where we have two intervals, all right, so an x-axis and y-axis, and we want to measure and understand the relationship between these two variables, all right, when they aren't necessarily in a completely independent relationship, like a line, for example, or a function above. But so for our main method for gathering discrete data in terms of if we've got two variables and plotting them is with a scatter plot. In other words, here in this example, you've got grip strength and arm strength, and we're looking for some sort of relationship between this individual, for example, who measured about a 30 in grip strength and a 20 in arm strength, something. We're trying to relate these two variables. So we would conclude there is a relationship between two variables if we can see a clear pattern in the scatter plot. Right? The pattern could be in the form of a straight line or a curve or any definite shape that appears. Right? However, on the other hand, if the scatter plot shows sort of a random cloud of dots or no clear pattern, right, we would conclude there is no parent relationship. Correlation, specifically talking about correlation, is a measure of a linear relationship between two variables. So specifically a linear relationship. In other words, it says how much your scatter plot might look like a straight line. Right? If all points on the scatter plot are perfectly aligned, it would be an example of perfect correlation. We'll see that again later in the Excel video. So if there is some important remarks. If there is a correlation between two variables, then there is a relationship between them. If there is no correlation at all, there could still be a relationship. Right? And again, this relationship does not imply causation. In other words, it does not imply X causes Y. Right? But we are looking to measure and establish relationships between variables. So we can measure correlation precisely through the calculation of the correlation coefficient. The nitty-gritty of this is going to be included in sort of the in-depth video, all right, and the notes that accompany that. But we denote this correlation coefficient with R. Okay, so this is a number between -1 and 1 with the following interpretations. So when the absolute value of R is 1, it's a perfect correlation. All points on the scatter plot are on a straight line. Okay? If it's between 0.5 and 1, the absolute value, then there's a strong correlation, and so on and so forth, reading through the different interpretations. So a positive correlation means that the scatter plot looks like a line with a positive slope. Similarly, a negative correlation means the scatter plot looks like a straight line with a negative slope. Right? And we'll see some examples of that. Right, but these figures, this is stolen from Wikipedia, but display many examples of scatter plots with their associated correlation coefficients. So you notice that this right here has a perfect correlation. It looks very much like a straight line. All right, and this is also a perfect correlation. Right, over here on the right-hand side, very much a straight line. Now notice we see that there is a positive correlation and a negative correlation. Right, as one variable increases, right, another variable tends to increase, and vice versa here. One variable increases and another decreases there. Okay, and so here we have something that looks like an 8/10 in terms of R value, 0.4, 4/10. All right, so this would be a medium correlation. This would be no correlation, and then so on and so forth. Now notice here, all right, that here this would be a perfect positive correlation, and here would be a perfect negative correlation over here on these three. Okay, notice that this 1 and the negative 1 has nothing to do with the slope of the line, all right, in terms of the size of the correlation coefficient, except for positive or negativity sign. Right? Positive correlation, negative correlation. Okay. All right. So here are some more examples of zero correlations, all right, or no correlations. That these variables still very much have a relationship. Would still very much have a relationship. The key is that they don't have a linear relationship. Okay. All right. So again, here's a note. The size of the correlation coefficient gives the strength of the correlation, has nothing to do with the slope of the line in terms of, right, this slope would be greater than this slope, but they're still both perfect correlations. So for a complete computational example, see the workbook, Excel workbook that I haven't titled yet, but go and see it. It'll be on Blackboard. All right, the last thing in terms of we've got correlation, this measure of a linear relationship. Well, once we have correlation, you'll often see a regression line, all right, or a straight line that quote unquote best fits the data, the line of best fit. All right, this is the line, mathematically speaking, that minimizes the vertical distance between the data points and the line. Okay, so of all the data points, adding up the vertical distance between them and the line, all right, it's the line that minimizes that total distance. Okay, so the regression line is used as a model for the relationship between two variables. However, it will only be a good model if the correlation is strong. All right, strength of the correlation indicates if the regression line represents a good fit for the data. All right, so here are two examples, all right, of regression lines. All right, on the left we've got a strong positive correlation, and on the right we've got a weaker, all right, correlation, and thus this regression line over here doesn't fit the data very well. Okay, and the equation for the regression line will be in the form of y tends to be written a plus bx. A is the y-intercept, b is the slope. All right, it's a linear equation. All right, from here on, there's an issue about making predictions. In other words, if we've got this data and we've got a line of best fit and a strong correlation, we might then say, well, what if we had an x value of 2.1, what might we expect for our y value? And you can make predictions from there. All right, it goes through an example. So the key is I wanted us to have an overarching viewpoint of everything. Now, we didn't discuss how to come up with this equation yet. All right, and we didn't discuss how to compute the correlation coefficient. Those are going to be in the in-depth video, all right, that follows. But this is for an overarching conceptual, do we understand the overview of these items?